Hello and welcome to this lesson about systems of equations. This lesson is an introduction to systems of equations, and the learning target of the video is knowing if a system of equations has a valid solution. So first of all, let me show you what a system of equations looks like. It could look something like this: 2x plus 3y is equal to 1, and then x plus y is equal to 4. You have several equations, and you're trying to, and that's what it is. And then so you can have different looks. Maybe you have something as simple as just 5x minus 2y equals 10, and then you have y equals 4. Again, you have multiple equations, and they're together. This is considered a system. This is another system. And so what we're curious about are x and y's, a point that would work for the systems, whether or not it would make it be true. Okay? Now, I have an analogy to kind of help connect all this stuff together. So let's use Venn diagrams. And let's say that I have one Venn diagram over here, or one side of it, and then I have the other side. And on the left-hand side, I want games that have boards on them, like a game board. And then the other side, I have games that have dice. All right, so boards and dice. And if we take a look at the games I have here, I have Candyland, Monopoly, and Yahtzee. Now, both Candyland and Monopoly, they have game boards, so they would go in here. And if we look at the ones with dice, Yahtzee has dice, definitely does, and Monopoly also has dice as the main means of moving players from point A to point B on the board. Well, taking a look at our Venn diagram, Monopoly is in both sides of it. So we should put it in the middle instead of in both of them. And that's what this area represents, is where there's some overlap between the two. So if we thought of each one of these circles as an equation, Monopoly is a value, is an xy that works for both equations. And so Monopoly is the solution. Monopoly is the answer. So that's a cool analogy and whatnot, but now let's take a look at an actual system of equations. So let's say we had something like 3x minus 2y is equal to 8, and then we have 2x plus y equals 3. And so what we're going to start off with today is just determining whether or not something is a solution. Eventually we'll figure out how to determine the solutions, but today we're going to see if something is actually a solution. So let's say we have the point 0, 5. So what we will do is test this point in both equations. So test in both equations, and it needs to be valid in both. If so, it's a solution. And so what I'm going to do is I'll take my top equation right here, and I'm going to put in 0 for 3, and then, whoops, not plus, minus 2 times 5 for the y equals 8. And keep in mind, we're testing, so it's equal sign with a question mark. And as you can see, we have 0 minus 10. Yeah, 8, no, it doesn't equal that. So this is not a solution. And that's all we have to do. We could stop right there, because if it didn't work for one, it doesn't matter if it works for the other. It's a moot point at that point. But now let's use the same system. So let me just rewrite it here. 3x minus 2y equals 8. 2x plus y equals 3. But now let's use the point 2, comma, negative 1. So we're going to go through the same process. We're going to test in both equations and see if it works. So I got my first equation. I'll go 3 times 2 minus, minus 2 times negative 1 equals 8, and that's an equals with a question mark. And let's see, so that's 6 plus 2 equaling 8. Check, that works out. Now, we haven't determined if this is a solution yet. So far, it's a great candidate for being a solution, but we have to test in the other one as well. So 2 times 2 plus -1 question mark equal sign 3, and we'll get 4 minus 1 equaling 3. Check. So since we do have 2 check marks, that means that yes, this is a solution. So it depends on how the question's asked, like is it a solution, or determine if it is a solution. So yes, that is a solution. Now, one thing I'd like to point out really quickly is that you could have this in a slightly different look, all right? So we could still have this one be like 3x minus 2y equals 8. Let me clean that up a little bit. But the second equation could be written a little bit differently. Y equals -2x plus 3. It's the same equation. All I did was I moved the 2x over to the other side. Even if it's displayed like this, it doesn't change anything. You'll still use your xy point. Just keep in mind that the 2 is the x and the -1 is the y. So when you plug it in, -1 question mark equal sign -2 times 2 plus 3. Nothing changes. You just have to be careful about where you place the x and y points. So now, let's go back to the analogy. And let's draw up another Venn diagram. All right, now on the left, let's say we want games that use cards as the main means of moving the players through the game. And then over here on the right, we will use dice as the primary means of moving a player throughout the game. Now, cards are used in Candyland. We're going to ignore these cards in Monopoly because while they are, sometimes they make you move, like it says go past go or go to jail or get out of jail, it's not the primary mover. The dice is the primary mover. And so Monopoly is over there and Yahtzee is also over here. And notice how there's nothing in between. And so when there's nothing in between, that means there is no solution. And this leads us to the different types of solutions we could have with systems of equations. So we have 3 types. The first type is just a regular old XY. And this is going to be like 95% of the equations we're going to encounter. All right? It's going to be an X and a Y. The second type will be no solution. And the third type has a long phrase, but it's the accurate phrase, infinite number of solutions. You can't say, all real numbers. So like when we were talking about solutions to equation, we said all real numbers works, but this is not quite as accurate. It's the same idea, but it's not the accurate verbiage for what's actually going on there. And so the other thing you're going to be expected to do is know which one of these do we have. So determining which case. Determining which type you have. And what you have to look for, slope and intercept. More specifically, the y-intercept. That's how you can determine which type you have. So, let's walk through a couple different situations here. Let's say we had y equals 3x plus 4 and y equals negative 2x minus 1. All right, so all we have to do is, first of all, look at the slope. If the slope is different, you're going to have one solution. So here, the slopes are not the same, so we will have one solution. And the idea is that if we were to graph this, 1, 2, 3, 4, one line's going to look like that. The other line is down here, going up 2 over 1, so it's going to look like that. they cross at that one point. That is their solution. But let's change things up a little bit now. So now I've changed it so that they both have a slope of 3. So if the slope is the same, we're now looking at a situation that, or let's see here. So this is going to result in having the same slope. But we don't know which one it is yet. But let's think about it graphically. So if we were to graph it, since they both have the same slope, they're just starting at different points, and essentially they're parallel lines. They're lines that will never ever intersect. So if the slope is the same, but these are different, we have no solution as the answer. No solution. All right. When could it possibly be all real solutions or an infinite number of solutions? Well, it could be that if we had the same line written twice. So let me show you what that could look like. Let's say we still have y equals 3x plus 4. But now watch what I do. What if I say for the other one, I have 6x minus 8 equals, no, that's not what I wanted to say. 6x minus 2y equals negative 8. Take a good long look at those two equations. You might notice something. Now, again, what I said is we have to look at the slope. Well, this one isn't written in slope-intercept form, so we need to solve that for y. So I would bump this over there, bump that over there. 6x plus 8 equals 2y. Divide everything by 2, and I end up getting y equals 3x plus 4. These are the same equations, and they are written, but they look different. And so if you have the same equation, the same slope, the same intercept, well then you're going to have the infinite number of solutions, INS, infinite number of solutions, because again, we've just written the same line twice. And that means you can take any one of these points on the line, and there's an infinite number of them, and it would work. All right? So those are the 3 different types of solutions. Just again to go over it, is that as soon as you have a different slope, so let me write it here. So this is going to be different slope. You have one solution. If the slope is the same, you either have a no solution or an infinite number of solution. No solution is different intercept. So same slope, different intercept. Infinite number of solutions is when you have the same equation written twice, but in a different format. So that's the introduction to systems of equations. Good luck on your homework or practice, and let me know if you have any questions.